So this is a study of occupant satisfaction in BREEAM Excellent certified buildings at Coventry University. Post-occupancy evaluation surveys were conducted in 3 Coventry University buildings that were all built between 2012 and 2019. The 3 buildings are known as the Hub, which houses our student university, our student union building, the ECB or Engineering and Computing building, which is part of the engineering faculty, and the Alison Gingell building, which is the health and life science building at the university. The post-occupancy evaluation surveys that we used were the Building Use Studies methodology, which is known as the BUS methodology, and we carried out a survey in 2 sections. So we did one in summer and one in winter in each building so that we were able to collect a comprehensive data set. In each version of the survey that we delivered, 30 occupants were surveyed in each building, which meant that overall we had a participation of a total of 180 occupants. The surveys, which you can see a sample of here, were handed out to the students who are just simple regular users of the buildings. And these participants were mainly selected from the communal spaces of the 3 buildings, such as the lobby and the reception area. So the first building is our Hub building, which houses our cafes and all of our student facilities, such as the student union. The design features of this building, which was constructed in 2012, are that it has low energy light fittings throughout, rainwater harvesting. It has an atrium designed to improve thermal comfort and indoor air quality. It has photovoltaics on the roof, and it has an open loop heat pump within the building that draws from boreholes down to an aquifer that flows underneath this building. That's taken into a chill beam setup within the Hub building. You can see from the occupant satisfaction levels of indoor environmental quality that within the Hub, the average vote on the IEQ scale are towards the more satisfied part of the scale, so 4 to 6. And you can see that in particular with the visual environment, with lighting, it scored very highly with 6. So the building has a deep compact plan with an atrium in the middle that contributes to this satisfaction because it maintains visual comfort and benefits thermal comfort in the communal spaces passively. The curtain walling on this building also is linked to a building management system which provides intelligent control of the internal environment. The second building that we looked at was our Energy and Computing building, or ECB, and this has some similar features to the Hub, so that it has an atrium. This is an offset atrium that goes across the 5 floors of this building. It also has heat. The air within the building is there's a heat exchanger on the roof. So there's a large thermal wheel on the roof that captures the heat from the exhausted air and puts it into the incoming air. So no heat is wasted within the building. There's a solar thermal array on the roof which preheats the water into the boilers so that it reduces the primary energy demand. There is a green roof on the lower part of this building, which we use for preventing flash flooding and for floodwater prevention. And there's also a rainwater harvesting system within this. The building is a concrete structure which has a high thermal mass, and we use this combined with the atrium as a passive stack, so that we do night purging in the summer months, where on top of the atrium there is a lantern with vents that open so we can purge all the heat that has been trapped within the concrete beams. This table shows the occupant satisfaction level of the indoor environmental quality in the ECB, and you can see that we've moved up a small little bit to between 4 and 5, so on the hub. They're definitely on the more satisfying part of the scale. This shows occupants' positive perception of the thermal environment, indoor air quality and visual comfort. You can see on the little inset pictures here the evacuated tube solar thermal system, and you can also see the green roof on the lower wing of the building. The facade of this building has an innovative honeycomb design which optimizes solar gain into the building, so that it has a shroud round it which reduces solar gain into the building in the summer months when the sun is high, and in the winter months when the sun is low in the sky, it reflects as much heat into the building as possible, so that again it reduces the primary energy demand. Another feature which we alluded to was we used the thermal mass of the building to our advantage by using that as a heat source, so that in the summer months we can reduce the amount of air conditioning within the building, because we use the thermal mass of the exposed concrete to store heat, and then that travels up the atrium, and we do night purging so that it flows out of the lantern on top of the atrium. But in the winter, it also enables us to effectively use the concrete structure as an additional radiator, so that we can perhaps turn the heating off a little bit earlier in the day. The final building that we assessed was the Alison Gingell building. One of the big differences with the Alison Gingell building, and one of the improvements that we made with the design of this on the hub building and also the ECB, was that it's a much more conventional shape, so that this is basically a rectangular shape, and we moved the atrium so that it wasn't a central atrium but was on the north side of the building. We also addressed the sound issues within this building by increased soundproofing within that building. And you can see from table 3 that the average satisfaction votes on IEQ are towards the most satisfied part of the scale, so between 4 and 5. We really tried to consider the complex relationship between indoor air quality, thermal, visual and acoustic environment. And so we designed the south-facing windows to bounce back and attenuate external noise from the adjacent road. We put acoustic panels, acoustic wood cladding, which you can see in the bottom right picture here, which covered the thermal mass of the concrete structure but provided some sound attenuation as well. The north side atrium provides a similar feature to what we saw in the ECB, which is stack ventilation, which improves the thermal environment, allows us to do night purging, and allows us to make best use of the thermal mass within the building. So in a conclusion, you can see that several other studies have shown the importance of atriums on improving indoor environment quality. There's a study by Wang et al. In 2017 that shows through overflow into the atrium, air with higher temperature returns to the heat recovery unit for the heat exchange with the new fresh and cold air outside. A study by Du et al. In 2020 highlights that large volume atriums equipped with a large number of indoor architectural structures can absorb the sound to a certain extent. The design of the atrium should focus on a balance between the light and the thermal physical environments. That's also from Du et al. Several other studies have highlighted the role of outdoor atriums or courtyards on improving the visual environment and indoor air quality, such as Corsavi et al. In 2017 and Gu et al. In 2012. The results show how integrating different passive and active strategies in 3 BREEAM Excellent certified buildings have impacted occupant satisfaction level towards the thermal comfort, indoor air quality, visual and acoustic comfort. The main sustainable architectural features used in all 3 of the buildings was the atrium, and that has, through the studies that we've undertaken, shown that it improves lighting comfort, thermal comfort and indoor air quality. Occupants within the atrium, though, may suffer from acoustic discomfort. However, when you attenuate that with things like acoustic panels to absorb extra noise, reduce reverberation time and improve the acoustic comfort, that can be overcome. So Coventry University's protocol is that we're aiming to deliver the best internal environment quality for occupants, and we've run post-occupancy surveys. In the Alison Gingell building, which is our most recent building, only 2 satisfaction factors have an average of 4. In the ECB, there's 3 satisfaction factors have an average of 4. And then the hub follows behind that. So we feel that we're learning and increasing the satisfaction within our buildings, and differences within those scores may be related to construction time. We've certainly learnt lessons from the past in terms of the types of atrium that we've installed, and we feel that the results of our IEQ surveys show that Coventry's approach to delivering better conditions for its occupants is working. And by way of an appendix, here is the ground floor plans of the 3 different buildings, together with a diagram of the environmental circle. Thank you very much.